Working with 5-axis terminology. Part 3. From and towards a line. So let's look at a definition for working from and towards a line. From a line is when the tip of the tool is constantly pointing away from a predetermined line that is positioned along a chosen axis. In the first picture, we can see that as the tool moves along a chosen axis, that the tip of the tool is constantly pointing away from the predetermined line. Working towards a line is the opposite. The tip of the tool is constantly pointing towards the predetermined line that is positioned along a chosen axis. So in the second picture, we can see that as the tool moves along a given axis, that the tip of the tool is constantly pointing towards the predetermined line. So let's look at some programming examples of how we can use from and towards a line. I'll be using Autodesk PowerMill to demonstrate this example. So programming from and towards a line. Firstly, we're going to look at programming from a line. So we have this standard 3-axis toolpath here, and what this is going to do is machine through that highlighted slot cavity through the component. So using this standard 3-axis toolpath, what I'm just asking the tool to do is to just trace up and down the wall and move along through the slot for the purposes of demonstrating this strategy of programming from a line and how that can benefit you in this type of feature. So we'll notice that when we get to anywhere along this wall to a particular depth, that we get a collision condition with the holder and the component at that point there. And as we've said in previous lessons, the way around this, if we're going to keep it as a 3-axis toolpath, would be to extend the cutter. But we want to keep the cutter as short as we possibly can. So we're going to introduce programming from a line to control the motion of this tool holder and the machine so that we do not have to extend that tool. So here we have another toolpath which controls the machine from a line and controls the movement of the tool from a line that we have predetermined that will control the movement of the tool holder, the machine, so that we get no collisions and we're able to keep that tool nice and short. Let's look at the settings on this toolpath. So this is a line projection toolpath to start with. So the toolpath itself is using a line which is struck through the section we want to machine. We should just be able to preview that here. So through that line, through that crosshead, and you can see the preview frame of where it's going to project. So from this line here, it's projecting the toolpath out to strike the surfaces that it can see. And what I have done for this feature is just created a bit of runoff using Fusion 360 just to get me a nice clean toolpath. So I'll just turn that off, but that surface is being used in the background. So this is a line projection toolpath. So if we look under the tool axis tab, we're going to be working and controlling our tool from a line. Now if I draw the tool axis and if I tick that here, that line there denotes and signifies the point, the anchor point of rotation that the tip of our tool will be constantly looking from to control its movements as it walks up and down these walls. So from our work plane here, I've told PowerMill to create a line at x minus 127.5, and at Z minus 75. And we are striking that line along the Y axis. So we have X, Y and Z, and we're activating the Y axis. So at those two coordinates, a line is struck going in the Y direction. So let's simulate that to see what that looks like. So you'll see that through that line, that tool, the tip of the tool, is constantly working from that line. And this enables us to prevent any collisions and maintain a nice short assembly. Let's just simulate that. So you can see how the tool constantly pivots from that line point, so that the tip of the tool is constantly looking toward or from that line, away from that line. So that would give us a nice safe toolpath moving all the way through that feature. Let's activate the machine tool to see what that would look like. From the machine tool, let's just activate the correct work plane to position our part on the table. And let's simulate that again, slightly slower, and see what that looks like on the machine. So you can see how the machine is using this line to pivot the tool to work all the way through that feature. So that's programming from a line. So let's see what that looks like using the automatic settings from within PowerMill. So I've told PowerMill, if we look at the settings for that toolpath, under the Tool Axis tab, put my main tool axis pull down window to vertical, selected the automatic collision avoidance, then under collision avoidance, just gone with the automatic option and put the 1mm envelope around the holder and shank, and just left it to PowerMill to choose the option here. So let's simulate that and see what that looks like. Yeah, so in this case I feel that working from a line has given us a much smoother, more predictable movements of the machine. We're to just speed it up and we'll see what that's like as it works through. Yeah, we seem to get some more unpredictable moves using that automatic option. So in this case, as I've mentioned before, I personally would feel that programming from a line has given us a better result than working from automatic. So that's what's available to you, and you have those options to use automatic or a more traditional method of programming from a line. So let's look at programming towards a line. And I've just chosen in this scenario here to literally just raster along this floor, up over this island and down the other side. To prevent it going into that casing there, I just used PowerMill modelling to create a surface to cap off that hole there. This is a standard 3-axis toolpath, and we'll see that at some point along this wall here you're going to get some collision happen with the holder. I think if we just walk that down, you'll see you can see that the holder is hitting the component. So working towards the line is the way around this. As we've said before, if we want to stay with using the vertical option, we would have to extend the tool. We want to keep that tool as nice and rigid as possible. So we program towards a line. So in this case, you can see we've already got that tick box drawn, so you can see the line here. So under the settings, we've chosen towards a line, and I've asked PowerMill at x0 and y0 put a line in the y direction at minus 250 mil. So now the tool, PowerMill will create exactly the same toolpath, but the tip of the tool constantly point towards this line here. Let's just simulate that and see what that looks like. So we can keep our tool nice and short, and using this method we are getting just the right tilt so that no collisions happen between the holder and the component. And that will make its way all across there. So that's programming towards a line. So typically programming towards a line would be used to program external features, such as external bosses or male cores on a die or pattern, so that you can keep that tool short. And likewise, programming from a line will be used on internal features, such as slots, like that one maybe, or female cores on a die. And that again allows you to keep a short, rigid tool so that we can maintain an excellent surface finish, but also increase cycle time because we can push up that data. So if you're new to 5-axis, I hope that's helped you to understand a bit more about the terminology of programming from and towards a line.